All right, this is going to be 21 to 30. So starting with 21, we have 1 minus sine squared theta over 1 plus tangent squared theta equals cosine to the fourth theta. On this problem, the more complicated side is on the left. And remember, you should always be checking for Pythagorean identities when a 1 plus or minus is involved with a trig function squared. So 1 minus sine squared theta is equal to cosine squared theta. 1 plus tangent squared theta is equal to secant squared theta. I used Pythagorean identities for both of those. The first one was rearranged. The second one was the original. Instead of dividing by secant squared, we can say multiply. So secant squared is 1 over cosine squared. Instead of dividing by 1 over cosine squared, we can say we're multiplying by cosine squared over 1, and that is how we get cosine to the fourth. For 22, we have sine theta over cosecant theta plus cosine theta over secant theta is equal to 1. So this one, again, kind of uses that same skill that I just did. Cosecant is 1 over sine. So if you're dividing by 1 over sine theta, you can rewrite this as sine theta times sine theta over 1. And same thing here. This can be cosine theta. Instead of dividing by 1 over cosine, you can say multiply by cosine over 1. And that gives me sine squared theta plus cosine squared theta. And that's equal to 1. Okay. Now we're going to go on to 23. Sine theta plus tangent theta over 1 plus secant theta is equal to sine theta. So I don't see any Pythagorean identities. Nothing is squared around here. So the next best bet is to change everything to sines and cosines. So rewrite tangent using the quotient identity as sine theta over cosine theta. And rewrite secant using the reciprocal identity as 1 over cosine. Now we have a complex fraction here. You can either do the addition in the top, do the addition in the bottom, and then multiply by reciprocals. Or I always like using this streamlined way to clear out complex fractions. We did this in our rational functions chapter, and it's showing up again here. If you just multiply by 1, but make it cosine over cosine to clear out these denominators, that will get rid of the complex fraction for you and usually means that you have less steps to write out. Okay, so if we do that, if we distribute the cosine through, we get sine theta times cosine theta plus second term, the cosines will cancel, so just plus sine theta. In the denominator, cosine times 1 is cosine. 1 over cosine times cosine is plus 1. Oops, how does this help? We're supposed to just be left with sine. So take a look at what you have before you go multiplying by conjugates. There's a little bit of factoring that can be done in the top. Take out a greatest common factor of sine theta. And that allows you to see that now you can cancel out a cosine plus 1 and a cosine plus 1. Those divide out to 1. So we're left with sine theta. All right, number 24. 1 minus tangent squared theta over 1 plus tangent squared theta. This one seems familiar. Equals 2 cosine squared theta minus 1. If we didn't have the same exact one, we've definitely seen this fraction before. Okay, so what have we done in the past? More complicated side is on the left. One of these is a Pythagorean identity. It's 1 plus tangent squared. So let's just start there. Just replace the denominator with secant squared instead of 1 plus tangent squared. And then you could write in terms of sine and cosine and get rid of your complex fraction. Or I like to use the Hart method, which is just says you're allowed to divide every term in the top by this binomial or by this monomial common denominator here. 1 over secant squared theta minus tangent squared theta over secant squared theta. And let's rewrite this. So 1 over secant squared theta is just cosine squared theta. And let's work on this. Tangent squared is sine squared theta over cosine squared theta. Instead of dividing by secant squared, I'm going to multiply by cosine squared over 1. So cosine squareds cancel. And now we have cosine squared theta minus sine squared theta. We're supposed to show that this is equal to 2 cosine squared theta. So what do we do here? Well, minus 1. So there is no sine squared on the right side. So let's replace that with our Pythagorean identity. Sine squared is equal to 1 minus cosine squared theta. So I'm going to keep that quantity in parentheses since I'm subtracting all of it. And if you distribute that negative through, you're going to get cosine squared plus cosine squared, which is the 2 cosine squared. And this will become minus 1. All right. Let's take a look at 25. So 25 is secant theta minus tangent theta sine theta is supposed to equal 1 over secant theta, right? Starting on the left side, I don't see a greatest common factor, so I'm just going to write in terms of sine and cosine. So 1 over cosine theta minus sine theta over cosine theta times sine theta. These already have a common denominator, so let's merge this fraction together. It's 1 minus, this will be sine squared, theta over cosine. I see a Pythagorean identity here. That's cosine squared theta over cosine. The cosine on the bottom cancels with 1 on the top. So we're left with cosine theta. Now this is kind of weird because this proof wants us to rewrite this as 1 over secant. We don't usually do this, but cosine is equal to 1 over secant theta. All right, 26. 1 plus cosine theta, we've seen this before, over sine theta equals cosecant theta plus cotangent theta. Now, if you start on the left side, you're going to either use the Hart method or maybe you multiply by a conjugate. If you start on the right side, you can write in terms of sine and cosine. So maybe I'll do that. So let's see. Cosecant is 1 over sine theta. Cotangent is cosine theta over sine theta. These already have a common denominator, so merge the fractions together. And I know we've seen this fraction before, and we've seen this separate setup before, but this proof is done after 2 steps. So maybe we haven't seen this exact problem because I don't remember one being that incredibly short, but yeah, that worked out. And if we did it the other way, Hart method, 1 over sine plus cosine over sine would have been the same thing. We would have said equals cosecant plus cotangent. All right, 27. Secant theta times sine theta over tangent theta plus cotangent theta will equal sine squared theta. Left side is more complicated. I don't see any Pythagorean identities, nothing to factor. So let's write in terms of sines and cosines. Now secant is 1 over cosine multiplied by sine. So let's just make that sine theta over cosine theta, which I know is tangent, but that's not really going to help me down here. Remember, you're not allowed to cancel if there's addition in the denominator. So let's keep this as sine over cosine and change these two. Sine theta over cosine theta plus cosine theta over sine theta. Now you can add your fractions together in the bottom, multiply by the reciprocal, or you can use the little shortcut that says multiply by the denominators that you see. There's a cosine here and here, and there's a sine. So if I multiply by cosine theta, sine theta, top and bottom, I'm multiplying by 1, and that's going to clear out the complex fraction for me. And I'll see what I have left. So in the top, the cosines cancel, but you're left with sine squared, which is a good sign. We're supposed to get that in the end. In the bottom, the cosines would cancel, and you'd be left with sine squared again, plus, in the second fraction, the sines would cancel, left with cosine squared. And of course, we know sine squared plus cosine squared is equal to 1 because of the Pythagorean identity. So this is equal to sine squared. Remember, in our notes packet, we proved why the Pythagorean identity exists. All of these rules are coming from just unit circle trig. So go back and review those now that it's not all brand new. If you're really wondering, like, why are all these rules happening and what's going on? Okay, now 28. This is silly. I'm not doing 28 because I just noticed. Take a look at 28 and 26. They're the same thing. We just flipped the sides. So I'm just going to say C26 for that. That's silly. 29 is cosine squared theta minus sine squared theta equals 1 minus 2 sine squared theta. We made a substitution like this a couple problems ago. I'm trying to find it. Back here on number 18. So this is similar. All we have to do is take a look at what we're missing. So I'm going to start on the left side. The right side does not have cosine squared, so let's get rid of that. Let's replace cosine squared with 1 minus sine squared theta, and then you're subtracting this other sine squared theta. And if you just combine like terms, you get 1 minus 2 sine squared theta. This expression, cosine squared minus sine squared, is an identity that we're going to learn after this first quiz. So we're getting used to manipulating it now, and we'll see it a lot in the future. So same idea with this one. Just looking ahead a few days, we're going to learn that cosine squared minus sine squared is equal to a different trig identity. So on 30, I don't have any sine squared. I only have cosine squared on the right, so let's get rid of the sine squared. So cosine squared theta minus the quantity 1 minus cosine squared theta. Distribute the negative, and you get 2 cosine squared theta minus 1. Great. That's our last one for this video. The next set of 10 will be in the next video.